Hello, future engineers. Here is another video in plane trigonometry. This is about familiarization with the trigonometric function values of common angles such as 0 degree, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And for other common angles, especially on uh, concept on reference angles, then we will have another video for that. So let's focus first on these uh, common angles, and I hope that you don't need calculators in determining the trigonometric function values of these common angles. So the guide would be as shown. So find the values of the six ratios for the angle 0 degree and 90 degrees. So of course, we draw a right triangle, although 0 degree is actually a straight angle where the terminal and initial side coincide. We just draw a right triangle and define 0 degree here. So the opposite should be 0, A is 0, and the adjacent side should be 1. And by Pythagoras theorem, the hypotenuse should be square root of 0 square plus 1 square. So that's why we also have 1 here. Of course, opposite to 0, because the sum of the interior angles of a triangle is 180 degrees, so each of these angles should be 90 degrees. In particular, I'll just call angle B here as 90 degrees. So sine of 0 degree is opposite, which is 0 over hypotenuse 1. So sine of 0 degree is equal to 0. So I hope that you can imagine, you can visualize uh, 0 degree and 90 degrees so that you can state the values of the six ratios from 0 degrees and from 90 degrees. So this is equal to 0. And of course, the reciprocal is 1 over 0, and that is undefined. So cosecant of 0 degree is 1 over 0, and it is undefined. Then we have cosine of 0 degree, which is equal to adjacent side B, which is 1 over hypotenuse 1. So cosine of 0 degree is 1 over 1, and it is equal to 1. While the reciprocal secant is also 1 over 1, so it is also equal to 1. Secant of 0 degree is equal to 1. Then we proceed to tangent of 0 degree. Opposite 0 over adjacent 1. So tangent of 0 degree equals 0. So I hope that you don't need a calculator to determine the six ratios for the angle 0 and 90 degrees. Then cotangent of 0 degree is adjacent 1 over opposite 0. So it is undefined. Then for the 90-degree angle, sine of 90 degrees opposite 1 over hypotenuse 1. So it is equal to 1. While its reciprocal is also 1. Cosecant of 90 degrees is hypotenuse 1 over opposite 1. So it is 1. Then cosine of 90 degrees is equal to adjacent side 0 over hypotenuse 1. So it is equal to 0. And the reciprocal secant of 90 degrees is 1 over 0, hypotenuse 1 adjacent to 90 degrees 0, so it is undefined. Then tangent of 90 degrees is opposite to 1 over adjacent side 0. So 1 over 0 is undefined. Tangent of 90 degrees is undefined, while the reciprocal cotangent of 90 degrees is adjacent side 0 over opposite 1, so it is 0. We then have 30 degrees and 60 degrees. And to do that, we consider an equilateral or equiangular triangle, and the sides would be chosen to be 2 for direct calculations or determination of these 6 ratios. You can have it 1, but this is the convenient sides of the equilateral triangle. So that when we drop, so each angle is 60 degrees, so that when we drop perpendicular from B here, perpendicular to the opposite side BC, it will be perpendicular and it will also bisect that opposite side. And that's 90 degrees. So this is 1 unit. So that's 30 degrees also. The angle is bisected. This is 1 unit. So first for 30 degrees, and that's 1 unit also. So sine of 30 degrees is opposite of 30 degrees, which is 1 unit over hypotenuse 2. So sine of 30 degrees is 1/2. And I hope that you can remember that. Just remember this equilateral triangle, and it is bisected. And of course, you have to remember that sine of 30 is 1/2. So that the reciprocal cosecant of 30 degrees is 2 over 1, and it is equal to 2. Then I'll call this adjacent side to 30 degrees, considering the left-right triangle as A. By Pythagoras theorem, it is square root of hypotenuse 2 square minus opposite 1 square. So it is square root of 3. So that cosine of 30 degrees is adjacent side A, which is square root of 3 divided by hypotenuse 2. So cosine of 30 degrees is equal to square root of 3 over 2. While the reciprocal secant of 30 degrees is 2 over square root of 3. By rationalizing the denominator, we multiply square root of 3 over square root of 3. So it is 2 square root of 3 over 3. Secant of 30 degrees is 2 square root of 3 over 3. Then tangent of 30 degrees is opposite 1 over adjacent A square root of 3. And if we multiply square root of 3 over square root of 3, it is square root of 3 over 3. Tangent of 30 degrees is square root of 3 over 3. While the reciprocal cotangent of 30 degrees is square root of 3 over 1, so that is square root of 3. Then sine of 60 degrees is equal to opposite A, which is square root of 3 over hypotenuse 2. And also take note that sine of 60 degrees is cosine of 30 degrees. Remember, the sine of an angle is equal to the cosine of its complement. So that's why they have the same values. So sine 60 degrees is square root of 3 over 2, while the reciprocal secant of 60 degrees is 2 square root of 3 over 3. Or 2 over square root of 3 times square root of 3 over square root of 3. So 2 square root of 3 over 3. Tangent, cosine of 60 degrees is adjacent side 1 over 2. So it is 1/2. That's why it is also sine of 30 degrees, 1/2. Sine of its complement. While secant of 60 degrees is 2 over 1, so it is 2. Then tangent of 60 degrees is equal to opposite square root of 3 over 1. So square root of 3, tangent of 60 degrees is square root of 3, just like tangent of 30 degrees. Tangent of its cotangent of 30 degrees, square root of 3. While cotangent of 60 degrees is square root of 3 over 3. 1 over square root of 3 or square root of 3 over 3. So that's it for this video. I hope that you're now familiar with the 6 ratios for 0 degree, 90 degrees, 30 degrees, 60 degrees, and the last is 45 degrees. So for the 45 degree angle, let's have a square of units sides 1 and 1 here. So if we divide the 90-degree angle, it will be bisected to 45 degrees. And the length of the hypotenuse or the diagonal will be square root of 1 square plus 1 square. That's why you have there square root of 2. This is also 45 degrees. So sine of 45 degrees is also cosine of 45 degrees. It is 1 over square root of 2. Then rationalizing the denominator, it is times square root of 2 over square root of 2. So 2 square root of, it is square root of 2 over 2. Sine 45 degrees equals cosine 45 degrees equals square root of 2 over 2. While tangent of 45 degrees, cosecant of 45 degrees is secant of 45 degrees. It is square root of 2 over 1, so it is square root of 2. While tangent of 45 degrees equals cotangent of 45 degrees, it is 1 over 1, 1 over 1. So opposite over adjacent or adjacent over opposite, that's the same. 1 over 1 or simply 1. So that's it for this video.